All right, let's look at an example of a molality problem. And again, the molality equation that we've introduced in class is very similar to the molarity equation, which was in the last couple of videos here. Molality is abbreviated as a lowercase m, and you see at the top of the screen here, a lowercase m. Usually when it's in typing on a screen or on a piece of paper, it'll be in italics, but molality is always lowercase m. Be very, very careful when you're showing molarity or molality that you're very specifically capital or lowercase m's. Don't make that m that's kind of halfway in between, because it's hard to tell which one you mean. So molality is lowercase m, and molality is moles of solute on the top, just like molarity was. But now it's divided by the kilograms of solvent, not the solution, but the kilograms of the solvent. So molarity relates solute to the solution as a whole. Molality relates the solute to the solvent. Now we're using different units, but we're still kind of relating or linking those two different things to each other. Molality feels a little different then, because the solute and the solvent are two separate things together entirely. In molarity, the solute and the solution on the bottom are, well, the solution contains the solute, so it's kind of there both ways. But when we're talking about molality, the solute and the solvent on the top and bottom are separate from each other really completely, even though they've been put together in a solution. Mathematically, we keep them apart. So it's not going to be any harder to solve molality, but they'll look a little different, and the information that you're given on a molality problem will be different, and you'll be asked sometimes to solve for different things. Just as with molarity, the molality equation has a basic three-part sort of core, and you see it here in black. However, moles of solute, again, as with molarity, can often come and go between grams of solute and moles of solute. You see it here. We can convert back and forth from grams to moles rather easily, and vice versa. And kilograms of solvent can often be represented first as grams of solvent that we have to convert to kilograms, or again, vice versa, kilograms back to grams. So this is very much like molarity, where we go from grams to moles, possibly on the top. We go from kilograms to grams on the bottom, whereas molarity had similar conversions of its own. So keep this equation close by, and let's go through an example. This is number 10 on the same assignment that we've been working from in the previous problems. And again, if you don't have a copy, just copy it down and work along with us. So number 10 asks you to calculate the molality of a solution. Molality, again, sort of the core of this equation on the far left. To do that, we need moles of solute, and we need kilograms of solvent. Well, let's see what we've got. It says calculate the molality when 75.0 grams of magnesium chloride are dissolved in 500 grams of solvent. I need moles and kilograms. I've got grams and grams. Seems like I'm not quite there. So to solve this problem, we're going to need to take grams of solute, which in this case is the magnesium chloride, and 500 grams of solvent, and convert both of those to their appropriate moles and kilograms. Now, how do I know which one's which? Well, this problem is very deliberate. It says grams of solvent. If it said grams of water, we'd have to think a little bit, but we'd usually think of water as a solvent, and we would treat that as the denominator of this math. Plus, if you look at the verb here, it says the magnesium chloride is dissolved in. So that tells us that the solute is dissolved in the solvent. So even if it didn't say solvent, we'd be able to figure out that magnesium chloride is our solute. So I've got 75 grams of magnesium chloride. That's this value on the top. And I've got 500 grams of solvent. That's this value on the bottom. Oops. And I'm going to convert both of those along the red arrows. So in order to find molality, which is what we're looking for in this problem, I'm going to need to convert grams into moles and grams into kilograms. And I'll get my molality by dividing those into each other. So let's start out with the top, grams to moles. 75 grams of magnesium chloride. Convert that to moles. I'm getting rather sloppy today. Apologize. If we add up the magnesium chloride's mass from the periodic table, its molar mass or gram molecular mass is 95.2 grams per mole of magnesium chloride. Make sure you got one magnesium and two chlorines there. And so when I divide that out, I'll get my moles. Grams will cancel out, as always. And when I convert that out, I get 0.788 moles of magnesium chloride. That's my solute. And so I've got grams converted to moles, 0.788 moles. That's this value up on top. And now I need to make my bottom conversion. 500 grams to kilograms. Well, just like milliliters to liters is for our molarity equation, 500 grams to kilograms is an old metric system conversion that you learned way back in grade school. And somewhere there's an elementary teacher hoping that you remember it. So 1 kilogram, 1,000 grams, very elementary kind of conversion. Grams cancel out, and I'm essentially dividing 500 by 1,000. Now I want to preserve my significant figures whenever possible. So 500.0, hopefully you see, has 4 sig figs here. So try to keep those so we don't lose our precision. When I divide, my calculator is going to spit out 0.5 because my calculator is lazy, but I'm going to know that it's 0.5000 kilograms, 4 significant figures. So I've got moles, I've got kilograms. I've got kilograms down here. And now I simply divide moles by kilograms, and I'll have my molality all done. So let's set that up for our final step. 0.788 moles divided by, and I'm going to put my solute on there, divided by kilograms, 0.5, half a kilogram of solvent. Moles over kilograms, and again, punch this in my calculator. When it comes out, I should get, with 3 significant figures now, 1.58 moles per kilogram. And when we abbreviate it, remember for molality, it's way up here at the top, molality is lowercase, italicized if you can, m. So 1.58 moles per kilogram is written as lowercase m, magnesium chloride. In this case, the solute. We label it with molality and then the solute. And keep in mind that just as for molarity, this little m, lowercase m, is moles per kilogram. Actually represents moles per kilogram. And if we were to read this out loud, we pronounce the m not as 1.58 little m, but as 1.58 molal solution. Kind of a weird word, but 1.58 molal magnesium chloride, or 1.58 molal MgCl2. And there's a difference in a lot of places in chemistry, that kind of the next level of solution problems, where molarity and molality, even though they look very similar in the calculation, actually have very, very different meanings for us at different times. So being able to calculate both is important, and know which one's which is important, even though they look pretty similar and are probably about equally difficult for you to calculate either one. So that's number 10, and we took grams to moles, we took grams to kilograms for our solvent, and then we put those two answers together to make a molality. 3 steps, that's as many as they can be. So all the example videos we've done so far include 3 steps. There'll be others that have fewer. I'll try to put together a video or 2 that shows some shorter problems so that you can see those too. But until then, we'll see you next time.